In this video, I'm going to show you how to conduct independent t-test using SPSS. So one thing about independent t-test is that we use it to find out the differences between the means in two unrelated groups. So when I say two unrelated groups, take it like gender. Gender we have males and females. So we use it to find out whether males and females will be more high or low on maybe organizational commitment. So when it comes to this data, in case you want to analyze independent t-tests for this hypothesis, maybe you're establishing a hypothesis that males will be more will have higher levels of organizational commitment than females, and you want to test. So one thing you need to do is that you come to analyze. Then under analyze, you go to compare means. Then you select independent samples t-test. So under independent, when this drop box pops up, the area known as test variables, that's where you move your dependent variable. And from the hypothesis, our dependent variable is is organizational commitment. So you move organizational commitment to the test variables. Then your independent variable, which is gender, you move it to where? To the grouping variable. So this is gender, move it to grouping variable. Then under grouping variable, you click on define groups. So under define groups, based on how you coded male and female. So when you're coding, maybe you indicated that, or you coded male as as 1. So it means group 1 will be 1. Then you coded female as as 2. So group 2 will be Will be 2. Then you click on continue. Then the next thing for you to do is to move to options. So under options, make sure that the confidence interval is 95%. So when you take that, or when you indicate that, it tells us that okay, you have about 5% probability that you might commit type 1 error. So then you go to continue. Then the next thing for you to do is to click OK. So this is the main the main data, the output itself. So when it comes to the independent t-test, two outputs will pop up. So the first table tells you the sample details. The sample details. When I say the sample details, it means that N stands for the sample size, sample mean, sample standard deviation, and sample standard error of the mean. So it means that in terms of males and females, the sample size for male is 229, then female is 182. So it means we were comparing males and females on on organizational commitment. And for you to know whether there's a difference between the two groups on organizational commitment, we use the means. So you can see that the means, the males, they had higher means than than the females. So to some extent, there's a difference. But one thing is, with inferential statistics, we don't just use the descriptive stat aspect to make conclusions. So it means you are supposed to You are supposed to move to the next table, which is the independent samples of T, to find out whether the differences we are having here is significant or not. So the second table, we are supposed to read and find out whether the differences between males and females, they are significant or not. So for you to read, go to this side where they've indicated equivariance assumed and equivariance not assumed. One thing about independent t-tests is that always we want something known as homogeneity of variance. So we need to test whether the variances are equal or not. So the Levene's test for equality of variance will let you have a fair idea as to whether the variances are equal or not. And one term rule about the Levene's test for equality of variance is that always use the sig value aspect. We have SIG and F. So you can use the sig value aspect. And one thing is, we say that if the SIG, also known as the p-value, when the p-value is is less than 0.05, then always assume that the variances are not equal. Yet at the same time, you can also use the F. When the F is what? Is greater than 1, the F value, it is greater than 1, then it tells you that the variances are what? Are not equal. So from this, it means that since the SIG is what? Is less than 0.05, we are supposed to assume that the variances are not what? Are not equal. So it means you are supposed to read our information from beneath. So put it at the back of your mind that when it comes to the Levene's test for equality of variance, it helps us to find out whether to read our information from the top or from beneath. Okay, so right now we know we are supposed to read our information from beneath. So for us to know that the differences are what are significant or not, we move on or we use what the sig value aspect known as two-tailed. So on this side, we read our information from beneath. So we will pick what? 0.100. Then yet at the same time, you're supposed to compare this value with what? With 0.05. And for you to know whether there's a difference between the two groups or not, there's a thumb rule. Always, when the p-value is what? Is less than 0.05, that's when it is less than or equal to 0.05, then it means that there's what? A statistical significant difference between what? Between the groups. Then when it is greater than what? 0.05, then it means that there's no what? Statistical difference between the groups that we are comparing. Okay, so from this, it means that the SIG here is what? Is 0.100. When you compare 0.100 with 0.05, 0.100 is what? Is greater than 0.05. So it means there is no what? Statistical significant difference among what? Among males and females in terms of what? Organizational commitment. So even though the first table is telling you, oh, the mean differences, they are what? They are not equal. You could see males, they had what? Higher mean difference than females. But the second table is telling you that this difference is not what? It's not significant. So that's how you do your interpretation. So it means that our final what? Our final interpretation will be that there is no what? Statistical significant difference among what? Males and females in terms of organizational commitment.